Hi everybody, Mrs. Gorman here, and this video is explaining the scheme for sedimentary rock identification. Let me tell you, if you guys understood all of the igneous rock chart and you feel okay about this, trust me, your sedimentary rock chart is a lot more straightforward. So let's get to it. You're going to need 5 different colored pencils. So I'm going to start with red, and the first thing I'm going to point out is that the sedimentary rock chart is broken up into two main sections. There's a top section and a bottom section. And although these are already kind of grayed in for you, I'm going to emphasize it. I'm going to take my red and highlight this banner here. And this is my inorganic, land-derived sedimentary rocks. And so inorganic means it's not formed from life. And land-derived is exactly what it sounds like. It's coming from the land. It's not forming in water. I'm going to go to blue. And so when we're identifying sedimentary rocks, looking at the texture is going to be the first step. You have to determine, okay, is it clastic, crystalline, or bioclastic? So let's talk about clastic first. The majority of your sedimentary rocks are going to be clastic. So what does clastic mean? It's not a word that people use too much, but right in parentheses underneath the word clastic, you see the word fragmental, and I think you all know what that means, right? Fragments just means pieces of things. Well, what pieces of what in this case? Pieces of different rocks. Small pieces of rocks are also called sediment. So I'm going to write the word sediment right there. And right, doesn't that make sense? If you go back to your rock cycle, sediments compact and cement together to make sedimentary rocks. So you have your clastic texture, and here are your clastic sedimentary rocks. We have conglomerate, breccia, sandstone, siltstone, and shale. So now the problem here is, okay, you have all of these different rock names, so what are they made out of? What are they made out of is going to tell us what they are. So we come to the composition. Oh my. It all has the same thing. They're all made of mostly quartz, feldspar, clay minerals, and may contain fragments of other rocks and minerals. So how do I tell them apart? Grain size. Your grain size is going to be the key, so I'll put little stars here, to actually identifying your different types of clastic sedimentary rocks. So, and what's nice is it goes in order from largest to smallest. You have pebbles, cobbles, and boulders. It says embedded in sand, silt, or clay. So pebbles and cobbles are pretty big. They should be pretty obvious to what you're looking at. Sand, I think you all know what sand looks like. And so sand is going to make up sandstone. Silt is going to make up siltstone. Clay is going to make up shale. I don't know why they don't call this claystone. They started with sandstone, siltstone. Well, they gave this one a fancy name and called it shale. But shale is made out of clay. If you've ever worked with pottery, you know that clay is a really small particle size, and if it gets wet, it even kind of feels a little bit slimy. In parentheses for sand, silt, and clay, it actually gives you the range of particle size. So sand is the name of a particle size. I know when you think of sand, you're just thinking of the beach, but sand is a very specific size of sediment, and it makes up sandstone. So here we go. Here is a rock. What do you guys think it is? Right, you should be kind of thinking, all right, I see very obvious gray material in here, and I'm hoping that you're picking up on the fact that those are pebbles. They're small pebbles embedded into a bigger rock. If I look at the other side, oh, that's a big guy. That's a huge rock right there. Most of them are smaller. So I'm looking up here. Okay, so it could possibly be conglomerate or breccia. The only difference between conglomerate and breccia is that conglomerate has rounded fragments and breccia has angular fragments. So what do you think? Do you think this looks more rounded or angular? Even this one looks like a triangle, but if you look at the edges, they are rounded, and so I would classify this particular rock as conglomerate. Okay, and that's it. That's all you got to do. When you're looking at other samples in hand sample, the texture is how they feel is going to give you the ability to identify sandstone from siltstone from shale. Shale is made out of clay, so it should feel really smooth in your hand. What do you think sandstone might feel like? Oh, sandpaper? Doesn't that make sense? Don't overcomplicate it, okay? Sandstone is going to feel like sand. So when you actually get the kits in front of you and feel for the texture, that's how you're going to determine sandstone from siltstone from shale. Okay, and those are your clastic sedimentary rocks. Let's go down to the bottom part of the chart here. And this has your chemically and or organically formed sedimentary rocks. So I'm going to take purple And go over this one, just make it stand out a little bit more. So chemically is referring to the texture crystalline. So I'm going to take my pen and I'm going to write chemical down here. Your chemical sedimentary rocks are rock salt, rock gypsum, and dolostone. And they all vary in grain size, so really how you're going to identify these types of rocks is based on their composition. Rock salt is made out of halite, right? And you should already know that halite is made of salt, or is salt. Rock gypsum is made of gypsum. Dolostone is made of dolomite. What we're going to focus on is how they form. Okay, so crystalline or chemical rocks are going to form when crystals from chemical precipitates and evaporites. Think about salt water. If you leave a cup of salt water out for an extended period of time, the water is going to evaporate, yes? The water is going to evaporate. What are you left with? Oh, you're left with just the salt. So I'm going to take my purple here, and I'm going to kind of put a box around evaporites. This forms, and you know what evaporation is, right? So the water evaporates, and you're left with the mineral. So you're left with salt. You're left with the gypsum. So these rocks usually form in water. A precipitate is when you have an overabundance of the mineral inside of water, and so it actually precipitates outside of the water. Or, I'm sorry, not outside the water, but in the water. But there's so much of the material that they actually start to come together and form the rock while still in the water. So that's a precipitate, and an evaporite is, again, when the water evaporates and you're left with the mineral. So those are the two ways that your crystalline or chemical rocks are going to form. We can highlight that yellow. And so limestone is sometimes both. Sometimes it forms by a crystalline way, and more commonly it's going to be bioclastic. What does bio mean? I know you took living environment last year, but biology is usually what it's called. Bio means life. Oop. Sorry, the lights go off on a sensor. So bioclastic means, that it was made from something that was once living. Well, plants were once living. Shell fragments, well, where do shells come from? Clams, bivalves, things like that. A biologic origin. So that's going to look something like this. You can see there's a little shell right there. Kind of looks like a granola bar, Rice Krispies. Students have all sorts of fun names for this. When you see it in hand sample, though, you should be able to see that there are shells, and that would make this limestone because it is cemented shell fragments. Boom. All right, and what is the composition? Is calcite. So if I took some acid and dropped it on here, it would definitely bubble. Sorry, I don't have any acid on me right now. Okay, you could also see a rock that looks like this. Okay, ooh, what's that? That is a fossil. Sedimentary rocks are the only rocks that contain fossils. And so this is an imprint of a shell. And so you know that, again, when you see shells or biologic fragments, this would also be limestone. Okay, last but not least, compacted plant remains. That's going to be your bituminous coal is how you pronounce that, bituminous coal. And so coal is black, in case you didn't know. I've had students question me because they say, hey, it's compacted plant remains and plants are green, so how come this doesn't have like any kind of green hue to it? What color is a plant when it dies, right? Maybe it turns like a little bit brown. The leaves are falling off the trees and they're brown, and then they're going to accumulate over time, and they are going to turn black. They're going to turn into soil. But if they're deposited quickly enough, they will turn into coal. And so coal is made of carbon. All living things have carbon in them. Okay, so those are your sedimentary rocks. Like I said, a bit more straightforward than your igneous rock chart. So I hope this is making sense to you guys, and you're feeling good about day one of sedimentary rocks. For the rest of the period today, you guys are going to be working on your mineral projects. All right, so I'm really excited. Periods 1 and period 4, you guys are doing your projects on Monday, and I'm really excited to see what we've got. We're going to use both double periods, so it is going to take up the whole time. I hope you guys are feeling good and prepared. Send me any questions if you have them over the weekend. All right, bye.